In this section, we're going to be formalizing slope and talking about how to find slope not only on a graph, but when given 2 points. First, we watched a video on Slope Dude, and let's talk about what Slope Dude reminded us of. The first thing he told us is that when we read lines, we're always going to read them from left to right. When the skier is going up the hill, that would be a positive slope. Puff, puff, positive. When he's coming down, that's a nice negative. On the straightaways, our skier says this is 0 fun. So that would have a slope of 0. This was a positive, this was a negative, that's 0. And then when he gets to the edge and he falls down, that was a slope of undefined. So there's 4 different types of slope: a positive, a negative, 0, and undefined. Slope by definition is the ratio. That's what makes us think of our fraction of a line's vertical change to its horizontal change. Now on a graph, when we're talking vertical, we're talking up, down, and when we're talking horizontal, we're talking left, right. So we have already talked a lot about rise over run to help us find or get to other points on the graph when we're graphing. So I know that if I'm standing on this point, I can rise and run to get to my next point. Here I have a rise of 3, 1, 2, 3, that's my vertical change, and I have a run of 6, which is my horizontal change, and that's going to simplify to 1/2, which means that this blue line has a slope of 1/2. Looking at my line, I can see that it's increasing as I read it from left to right, therefore it's a positive slope. So one slope formula that I already have is rise over run. Now another slope formula that means the same thing and that I can get directly from this definition that says ratio, so fraction, ratio. Vertical change, well on my graph, vertical axis is the y-axis, the horizontal axis is the x-axis, and the math symbol that means change is the Greek letter delta. It looks like a little triangle. So this formula says the slope equals the change in y over the change in x. You might hear it referred to as delta y over delta x. My last slope formula that's going to be brand new to us is what I like to call the subtraction fraction. So I still have my fraction, and it says that I'm going to do y2 minus y1 over x2 minus x1. And these little numbers here are called subscripts. They're below. They're not exponents. All this does is differentiate between 2 different y coordinates. So this is saying the second y coordinate minus the first y coordinate, and the second x coordinate minus the first x coordinate. We'll see this in action in a little bit. Now let's practice finding slope on a graph. So we've been using slope to help us graph. Now we're going to use the graphs to help us find slope. So if I want to find slope, I want to use that slope formula, rise over run, which means that I first want to find my rise, or my vertical change between my 2 points, and then I want to find my run, my horizontal change between my 2 points. So here I can see that it's 1, 2, 3, 4, 5, that's my rise, and my horizontal change is 1. So when I put these numbers into my fraction, my rise will go on top, my run will go on bottom, and then I'm going to simplify that, and 5 over 1 simplifies to 5. The last thing you need to do when using the rise over run formula is you need to take a look at your line and decide if it's increasing or decreasing. And I can see that this line is increasing. Notice when I counted my rise and run, I didn't worry about if I was moving up or down or left or right. I just counted my boxes. 1, 2, 3, 4, 5. Or I could have gone this way. 1, 2, 3, 4, 5. I didn't really pay attention until the sign of my slope until I was done and looked to see if it was increasing or decreasing. Let's look at the next example. So on example 2, I'm going to connect my 2 points vertically and horizontally. That vertical distance is going to be my rise, which in this case is 1, 2, 3. My horizontal distance is going to be my run, which in this case is 1, 2, 3, 4, 5, 6, 7. When I put these into my fraction, I always make sure that my rise is on top and that my run is on bottom. Now before I'm done, I want to check if my line is increasing or decreasing as I read it from left to right. So as I move along the line left to right, it is decreasing. Therefore, my slope is negative. Pause the video, try examples 3 and 4, press play when you're ready to check your answers. So on example 3, I have a rise of 2 and a run of 3, and my line is increasing as I read it from left to right, therefore my slope is positive 2/3. Now in example 4, you might be wondering where these numbers came from. So unlike these examples where the points were plotted for us, this one just had the line. What you can do is you can go ahead and insert points anywhere the line crosses at what you're sure are integers. Now remember, a line is really made up of infinite points anyway. So I happen to choose this point here and this point here. Now between these 2 points, the rise was 6 and the run was 2. 6 over 2 reduces to 3, but because my line is decreasing as I read it from left to right, that means that it's a negative slope. You might have chosen these 2 points right here, and if you had chosen those 2 points, what you would have ended up with for your rise and run would have been a rise of 3 and a run of 1. The magic of a linear equation or line is that it doesn't matter which points you pick, the ratio between them will always have the same slope. That's what makes it linear. So if someone else had chosen this point and this point, it would still simplify to 3. And since it's decreasing, it's going to be negative. Now what did slope dude tell us about these 2 lines? So in the video, when the skier was skiing on the flat, he said that that had a slope of 0. But let's look at this using rise and run. So between these 2 points, there is no up and down distance. So that means that my rise is 0. The run in this case would be 1, 2, 3, 4, 5. Sorry, I should have used green because that's what I was using before. Now what this really says to do is to do 0 divided by 5. Well, 0 divided by anything is 0. So it doesn't really matter what my run is. If my rise is 0, my slope is always going to be 0. If you were to type this into a calculator, it would tell you that the answer is 0. Now let's look at this one. So on this one in the slope dude video, this is what he said was undefined. It's so steep, we can't even define it. Now if I wanted to find the rise between these 2 points, it would be 1, 2, 3, 4, 5. But the run between these 2 points doesn't exist since they have no separation left and right. And so what this math problem says to do is 5 divided by 0. If you were to type this into a calculator, it would give you an error because you can't divide by 0. But we're not going to say that the slope is an error, we're going to say that the slope is undefined. So notice that these 2 examples both have a 0 in them. It's just that one has a 0 in the numerator and one has a 0 in the denominator. One little trick for you is a rhyme, and it's if the 0 is under the line, it's undefined. So now we're going to see how to find slope if you know 2 points on the line but don't want to graph. So in this situation, I know the line passes through these 2 points, and I could graph them and use rise over run, or I could use this formula here that I like to call the subtraction fraction. One strategy that I use when doing any of these types of problems is I actually like to set up my fraction first, and then I'm going to enter the information. So the very first thing that I'm going to do is I'm going to draw that fraction. So m equals, I've got my fraction with my subtraction. The reason I like doing this is because even if one of these numbers happens to be negative, that has absolutely nothing to do with the fact that it's subtracting. And so it's going to help me keep my signs in order. Next, I'm going to label all of my information. So remember, ordered pairs go x comma y. So the first thing I might do is label x, y, and then 10, 6 is also an x, y. So see how 5 and 10 are both labeled x? Well, we're not allowed to use the same variable to represent different things. So that's where these 1s and 2s comes into play. So 5 is the first x coordinate that I see, and 10 is the second x coordinate that I see. These little subscripts are just ways of differentiating between the first x and the second x. And then I'm going to do the same thing for my y's. So this is going to be y1, and so my 1's have to go together, and this is going to be y2. Now in my formula, I want to see how y2 comes first in the fraction before the subtraction, minus y1, then x2 minus x1. So before I actually enter this information, I'm going to go ahead and highlight the numbers in the correct highlighting color. So I've got y2 highlighted in red, and here's y2. I've got y1 highlighted in blue, and here's y1. I've got x2 highlighted in green, and here's x2. and I've got x1 highlighted in yellow, and here's x1. So now what I can do is I can just kind of match everything up and enter my information. So I'm going to enter in y2, which is 6, minus y1, which is 3, x2, which is 10, minus x1, which is 5. So y2, 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 y1, 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 x2, 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 x1, x1, x1. And now I'm just going to crunch the numbers. So 6 minus 3 is 3, 10 minus 5 is 5, which means that my slope is 3/5. That means that this line would have a rise of 3 and a run of 5. So let's try this again on the second example, example 6. So again, I'm going to start by putting my subtraction fraction, and I'm going to label my information. So x, y, x1, y1, x2, y2. And so then I've got, let's do y2, y1, x2, x1. And so now all I have to do is make sure I put the numbers in the right spots. So y2 is going to be 2, minus y1 is 4, x2 is 10, x1 is 8. And then I'm going to crunch the numbers. So 2 minus 4 is -2. If you find it more helpful, you can always do keep change opposite. And 10 minus 8 is 2. And so that means this is going to simplify to a slope of -1. So when it comes to slope, your answer possibilities can be 3 things. They can be a whole number like this, they can be a fraction like this, or they can be an improper fraction. What slope can never be is a decimal or a mixed number. So it always should either be in fraction form or a whole number form. At this point, pause the video, try examples 7 and 8, and press play when you're ready to check your answers. So on example 7, for y2, I've got -1 minus 2, which I could do keep change opposite to get -3. And for x2, it's 4 minus x1, which is 5, which is -1. -3 divided by -1 is +3. On example 8, I've got 6 minus 3, which is 3. And then x2 minus x1 would be 4 minus -2. It's important to see that this number is negative, even though it's minus. That's totally fine. And then what I can do is I can do keep change opposite in order to get 4 plus 2, which is 6. And then my slope of 3/6 will reduce to 1/2. Let's take a look at examples 9 and 10. And let's see what they have in common and maybe what a difference is. So I've got my subtraction fraction in each. And I've got x, y, 1s, 2s. Same over here. So ordered pairs always go x comma y, and if it comes first, it gets a 1. If it comes second, it gets a 2. So on example 9, y2 minus y1, x2 minus x1. This will be 0 over -2. On example 10, y2 minus y1, x2 minus x1. This is going to be 2 over, I'm going to do keep change opposite, and then -1 plus 1 is 0. So see how both of these examples have a 0 in the answer. Remember what we talked about with rise over run on the previous page. If I type this into the calculator, it's going to give me that 0 divided by -2 has an answer of 0. So this slope is 0. And if I were to type this into the calculator, 2 divided by 0, it's going to give me an error, which I now know means undefined. Also, don't forget that little rhyme. If the 0 is under the line, it's undefined. We can also prove this using a quick sketch. So if I were to sketch these 2 points, 4, 6, and 2, 6, that would mean I should go over 4 on my x-axis and then up 6 on my y. And then 2, 6 means over 2, up 6. And if I connect these 2 points, I would get a horizontal line, which I know has a slope of 0. So this matches my expectations. I could do the same thing with -1, 6 and -1, 8. So -1, 6 would be over 1 up 6, and -1, 8 would be over 1 up 8. And I'm just kind of doing a quick little sketch. That would get me a vertical line, and I know the slope of a vertical line is undefined. So now let's look at slope within a real-world context. So it said, Paul wrote the equation T equals 2m plus 40 to represent the temperature. So our variable T is representing temperature. in degrees Celsius, so we're measuring in degrees Celsius, after a substance has been heated for m minutes. So T stands for temperature and m stands for minutes. Describe the relationship between the temperature of the substance and the time it has been heated. Choose the best options to fill in the blanks in the order they're written. So this is a multiple choice question, where if we go with answer choice A, it would be 2 in the first blank, 40 in the second blank, and 1 in the third blank. And so we're going to try to figure out which of these answer choices is the best. So it says the temperature was initially blank degrees. The temperature increased by how many degrees Celsius every how many minutes it was heated. So I've got these two important numbers. I've got a 2 and a 40. Now I've got 240, 240, 240, 240. So the extra word in each of these answers is 1. So my question would be, where can I put a 1 in here? Where would I typically make something a fraction? Well, normally what I would do is I would take my slope and I would make it 2 over 1. Normally slope is with x, which I know is confusing because slope we know is the variable m, and this has m in it. But it's kind of similar to y equals mx plus b. So I've got 2 over 1, and then I've got a 40. Think about if you were to graph. Which of these two would you graph first? That's going to be your initial value. And we would start by graphing 40. That means our temperature started at 40. And then this means that the temperature increased by 2 degrees for every 1 minute it was heated. So it's 2 degrees for every 1 minute, and it was initially 40 degrees. So that answer choice is going to be B. What I want you to do on this one, so it says Lisa bought a silver chain. She wants to buy glass beads to put on the chain. The equation below can be used to determine y, her total cost in dollars to buy a silver chain and have X glass beads. So X is the number of beads that she's buying and Y is her total cost. And I'd like you to fill out these two remaining parts of the table. Notice that for 0 beads, her cost would be $10 because 2 times 0 is 0 plus 10 is 10. And for 5 beads, her total cost would be 20 because 2 times 5 is 10 plus 10 is 20. So you go ahead and fill out these remaining pieces. Pause the video, press play when you're ready to check your answers. So her total cost for 10 beads would be $30, 2 times 10 is 20, plus 10 is 30, and her total cost for 15 beads would be $40, 2 times 15 is 30, plus 10 is 40. So now the next question is, what does the 2 in the equation represent? Be sure to use a complete sentence and words that are connected to this specific problem. So we don't want to just say that 2 is the slope. Any equation written in this format has a slope. We want to be specific about what's going on. So you want to make sure that you're talking about either the cost, the chain, or the beads. So pause the video and do your best to come up with a sentence that would make sense here, and you can adjust your sentence after you're checking your answer. So in this case, the cost of each bead is $2. That's the significance of the 2. So a couple things to keep in mind is I mentioned cost, I mentioned beads, I mentioned the number we were talking about, and also the unit attached. So I know that it's more than just saying that the slope is 2. It's talking specifically about the cost of the beads being $2. Let's try the same thing, but this time let's talk about the 10 in the equation. Again, try to construct a sentence that is specifically related to the problem using language provided in the problem. Pause the video, press play when you're ready to check your answer. So in this case, the cost of the chain, or the 10, represents the cost of the chain being $10. So again, referring to cost of the item and units. And I also want to point out that this would be with 0 beads. Because in the equation, if my x value were 0, 2 times 0 would be 0, but I'd still be paying $10. That $10 must represent the cost of the chain. Lastly, we're going to show how we could use the equation to determine the number of beads to make the cost of the chain and the beads $200. So to do this, I'm going to take, so that's just a 10, I'm going to take this 200 value, and since it's $200, I'm going to put it in the place of the variable that represents cost. And in this case, the variable that represents cost is y. So I'm going to change y to 200. And so what I'm trying to figure out is, what would my x value need to be in order to make my y value 200? I could try to do this mentally, or I could solve it like an equation, doing reverse PEMDAS. So by subtracting 10 from both sides, which I would get 190 equals 2x, and then divide both sides by 2, which would make my x value, x would equal 95. So this would mean that in order to have a chain with beads that cost $200, I would need to use 95 beads.